Okay, let's just move our equation over here. Now, one possible approach is to plug each answer choice into the equation and see which ones work. Of course, that would take a while. Now, another approach is to see if we can first simplify this equation. So let's completely factor the numerator and denominator on both sides of our equation. When we do this, we get the following. At this point, recognize that since x plus 12 over x plus 12 typically equals 1, we can eliminate these two binomials from the left-hand side to get the following. At this point, recognize that the expression on the left-hand side is completely identical to the expression on the right-hand side. As such, we might conclude that every answer choice is a possible value of x. This, however, is not true. Now to begin, remember up here when we eliminated these two expressions because we concluded that x plus 12 over x plus 12 must equal 1. Well, this is not always the case. Notice what happens when x equals negative 12. When we plug negative 12 into our expression here, we get the following. And when we simplify, we get 0 over 0 is equal to 55 over 14. So, as you can see, our equation does not hold true when x equals negative 12. As such, negative 12 is not a possible value of x. Now, the same kind of thing applies down here. Notice what happens when we let x equal 2. Well, when we plug 2 in for x, we get the following. And when we simplify it, we get this. Now, some may say that 15 over 0 is equal to 15 over 0, but this is not true. 15 over 0 is an undefined value, so we cannot say that an undefined value is equal to another undefined value. So as such, 2 is not a possible value of x. Finally, what about this area? What happens if we let x equal negative 1? Well, when we do this, we get the following, and this simplifies to be 0 equals 0. So x equals negative 1 is a solution to our equation. So the only two restricted values for x are negative 12 and 2, and all other values are possible. So our answer is A, C, D, and F.